under fractions. Fractions. And the little subheading, if you will, is reducing by prime factorization. Reduce by prime factorization. Get that written down, and then I'm going to give you a problem here. If you would have something like this, let's just look at this fraction. 125 over 500. Not a pretty fraction by any stretch of the imagination. And if I asked you to reduce it, what number do you know goes into both of those numbers? Trevor?
25.
Okay. Sure, let's do that. Well, okay. Divide by 25. Divide by 25. I'm not sure how many of you can do that on your head, but 125 divided by 5 is, or 25 is 5. There's 5 quarters in a buck and a quarter. And 500 divided by 25 is, see, that's kind of a tough one there. It is 20. Maybe, let's do it like this. Maybe some of you, or any of you thinking just divide by 5, each one?
Yeah.
Just because they end in 5s. On the top, it still gives you what? 45 over 100. Then you could divide those by 5 again, right? And you'd get 9 over 20. I'm sorry. Wait, that's not right. What did I do wrong? This divided by 5. Oh, I'm sorry, this is 25. And divided by 5 is 5 over 20. And then 5 over 25 can be divided by what? Another 5, right? To get 1 over 4, correct? Okay, well the book is going to try to show you, in its own lovely little way, doing this whole thing kind of a different way, but yet it's still the same way. And that is this, to reduce by using prime factorization. And if they ask you to do this, you will not do this for very long, but if they ask you to do it, you have to do it because that's the way they want it done. So if they ask you to do this, and I will do it over here. I wish I would have started over here. What can I do to this? Do I can move it? Do I have the capability of moving this all up on my piece of paper?
Yeah.
Maybe.
The power of technology.
I'm going to try.
I think R missed R thing.
That's okay. I'll take that. Okay. So I'm going to do the same thing, that 125 by 500, but the directions from the book are going to say, well, reduce by prime factorization. Which you have to do like this. The first thing you have to do is actually prime factorize both numbers. So I've got 125 over 500. So off to the side here, I'm going to take 125 and break it down. What times what gives me 125? Anybody? 25 times 5. I can stop with 5. What times what gives me 25? 5 times 5. So here's my prime factorization of 125. 5 times 5 times 5, correct? Yes, Mr. Hahn, you are right.
Yes, Mr. Hahn, you are right.
Then I have to also do the same thing with 500. If I prime factorize 500, what times what gives me 500? Yes, 5 times 100. I'm sure somebody was saying that, just didn't want to think it. No, think it, just don't say it. What times what gives me 100?
10 times 10.
10 times 10. And then 10 is 2 times 5 and 2 times 5. So my prime factorization of 500 is, what do we have? 2 times 2 times 5 times 5 times 5. Now, for those of you that are observant, you will notice that this looks strangely a lot like some of the stuff we've already done. Right, Max? That's what Max was talking about. He asked about a problem like this. Well, here's the deal, and I think we've talked about this before. Step number 2 is this. If you have the same factors on top as on bottom, you can cross off like tops with bottoms 1 for 1. 1 for 1. Okay, which means if I see the same exact number on top as on bottom, I can cross them off. But I can't just, I don't take 1 5 and cross off the whole mess of 5s. I can cross off 1 5 with the second 5. I can cross off that other second 5 with the other 5 down there, and I can cross off that 5 with that 5 right there. There are no 2's on top, so I can't cross those off. Okay? Then step number 3 is to then remultiply what is left. I think we did this before. Now here's the one thing you have to be careful with this, is if everything crosses off, you're always still left with a 1, especially if it's on top. Everything crosses off, you're always left with a 1. So I'm left with a 1 on top, and then on the bottom I have a 4. So the whole thing reduced down to 1/4, which is what we got up here when we did it. You'll notice, what did we see here? Divide, divide, divide. What did I have here? 1 5 2 5 3 5s, 1 5 2 5 3 5s. On the bottom, 1 5 2 5s, 3 5s, and 4 is 2 times 2. So it's a different way to reduce it. It's a little more cumbersome, but it gives you kind of the feel of what you're doing when you reduce. You're just taking prime numbers and dividing into it. Maybe you've got that, maybe you do. Let's do another example, because I can tell you're mesmerized by it. Yes, mesmerized?
Yeah.
Now, the nice thing is, children, we'll go back to this thing. Once you've prime factorized 125, if you've already got that in your notes or you already know what it is, you really don't have to show it to me. You can just put down the 5. For example, what number comes up an awful lot is like 1,000. Let's say I had 125 over 1,000. Okay, I already know that the prime factorization of 125 was what same thing I just did, which was what? 5 times 5 times 5, right? Does anybody remember 1,000? With the prime factorization of 1,000? Anything that ends with 1 and a bunch of zeros, 1,000 is 10 times 10 times 10. And every 10 is 2 times 5, 2 times 5, 2 times 5. So 1,000 is 1, 2, 3 2s and 1, 2, 3 5s. Along that same note, do you see the pattern there? 100 is what? 10 times 10, so it would be 2 2s and 2 5s. Guess what 10,000 would be? It's following that same pattern. If 100, 2 zeros had 2 2s and 2 5s, 1,000 had 3 2s and 3 5s, guess what 10,000 would be?
4 2.
Yeah, 4 2s and 2 5s. So there are some shortcuts that you can see and take given all these big numbers, because it will take you a second. Now, what does this all cross off to? If you're crossing stuff off over here, you would end up crossing off this 5, that 5, this 5, that 5, this 5, that 5. Again, if everything on top crosses off, you have to keep a 1 up there. And what is on the bottom? 2 times 2 times 2. 8. If you do this right, you will always get the fraction reduced to its lowest terms. I suppose we should try something a little harder. Or a little easier maybe. Like 36 over 81. And maybe, ladies and gentlemen, 36 over 81. Some of you are at a point in your mathematical lives where you maybe can do some of this prime factorizing a little bit more in your head, and I'm okay with that as long as you show it to me. For example, what is 36? 4 times 9, right?
Yeah.
And how do I write 4 times 9? Well, 4 is 2 times 2, and 9 is 3 times 3. This is the prime factorization of 36. You know, if you have to do the tree thing, by all means, 4 times 9, but you might be capable of doing this with 2 times 2 and 3 times 3. Just like 81. What times what gives me 81, Marilyn? 9 times 9. And what gives me 9? 3 times 3. So what are you going to have here? 3 times 3 times 3 times 3, because that is 9 times 9 to give me 81. Now, what's going to cross off here? No 2's on the bottom, so those 2 have to stay. 3 and a 3, a second 3 and a second 3. Nothing else crosses off. Don't forget you have to remultiply. What do I get if I remultiply that? 2 times 2 is
4.
And 3 times 3 is
9.
So you end up with 4 9s. Again, it's not something they're going to make you do forever, but for right now, you know, if they ask you to reduce using prime factorization, that's what you need to show me. Yes, Tyler.
Is it possible to have like all the numbers on the bottom crossed off?
Yes, if all the numbers on the bottom cross off, you're just left with the top. Let me see if one actually happens. I don't. Well, it would. If that happens, it would be a little bit like, well, the 500 divided by 125. If you had 500 and a 125 on the bottom, it'd have to be an improper fraction. You know, 500, if you look back in your notes, was 2 times 2 times 5 times 5 times 5. 125 is 5 times 5 times 5. So these 5s would all cross off. You still really have a 1 on the bottom and a 4 on top, but if you have 4 over 1, that's the same exact thing as 4. So you don't need the 1 because that's exactly what it is. So if everything on bottom crosses off, you don't have to have it, but if everything on top does, you do have to have it. Is there another question out there? Let me give one for you to try here in the excitement of your own home here. How about 875 over 1,000? And again, we already did 1,000, so it's my hope that you don't have to sit and redo that again. Don't reinvent the wheel. You could write down the factors we did for 1,000 not very long ago. 875 you might have to take a little time with. That one might take you a little bit more. I'll give you a second to try that and see what happens. $875 would not be one I'm thinking you could just jot down off the top of your head. It gets a little more cumbersome. You might get it down to something where you could. You get an answer yet? You still calculate 875 as what times what gives me 875? 5 times 1 what?
105. 5.
It'd have to be 175. And then 175 could be broken down to 5 times 35.
Yeah.
And then 35 would be 5 times 7. So there's your 3 5s and the 7 up here. And then if you're looking at what crosses off, 5, 5, 5, 5, 5, 5. You're left with the 7 on top, and 2 times 2 times 2, which is 8 on the bottom. Questions on that, children? Like I said, it's a little cumbersome.